Welcome back to the AEC Leadership Channel. I'm Dr. BTA. It is June 2026, and across the global built environment, Q2 is wrapping up under massive pressure. Materials are moving, budgets are tightening, and leadership teams are scrambling to keep projects on track before the Q3 pivot. But here is the reality that trips up almost everyone. We are trying to solve 2026 problems with a 2016 playbook. In this month's field review, we are looking back at the past month to analyze critical shifts in market, performance, policy, and people across our three core disciplines: architecture, engineering, and construction. Let's dive in. The June AEC briefing, top 12 headlines. For architecture, 1. The Spatial Data Mandate. Late-stage changes from poor early programming account for up to 70% of downstream design delays. 2. Performance decoupling. Leading practices are reducing operational carbon footprints by 40% while preserving structural durability. 3. Advanced facility programming. Public safety facility updates show a 15% increase in upfront programming validation checklists. 4. Adaptive spatial reuse. Commercial office vacancies hitting historic regional levels spark a 22% increase in civic conversions. For engineering. 5. The infrastructure scale-up. Municipal capital audits flag 35% of public infrastructure builds for strict EVM monitoring. 6. Digital twin proliferation. Traditional non-streaming MEP models see a 30% drop in owner acceptance across new contracts. 7. Resilient facility engineering. Stricter municipal microgrid codes require a 2.0 times redundancy multiplier on critical backup power arrays. 8. The sensor-driven envelope. Deep foundation infrastructure projects see a 25% increase in fiber optic smart sensor integration. For construction. 9. Autonomous information environments. Automated data workflows reduce manual data administration hours by up to 45%. 10. Supply chain lead time realities. Volatile lead times on specialized mechanical components stretch past 42 weeks, dominating critical parts. 11. The ISO 19650 standard in action. 55% of major general contractors now mandate strict ISO 19650 data environments for subcontractors. 12. Pracademic field operations. Data-driven superintendents deploying precise project controls to lower field variance to under 3%. Segment 1. Architecture, data, decoupling, and spatial geometry. 1. The Spatial Data Mandate. Project design performance is completely stalling out in late design development because design teams are moving ahead into production with incomplete early programming. Industry case studies reveal that late-stage coordination changes from poor early programming account for up to 70% of downstream design delays. When you treat spatial data as something that can be figured out later, you create a compounding bottleneck. If spatial workflows and granular dimensions are not locked down upfront, your production teams end up trapped in endless cycles of late-stage redesign, destroying your baseline schedule performance. 2. Performance decoupling. On a more positive note, we see an extraordinary milestone in sustainable design performance with performance decoupling. Architecture firms are successfully separating high-tier structural building performance from historic operational carbon baselines. Leading sustainable practices this year are achieving up to a 40% reduction in operational carbon footprints while fully preserving structural durability. We are proving that structural longevity and ultra-low environmental impacts can coexist if simulated early within predictive data environments, completely shifting our carbon expectations. 3. Advanced facility programming. This structural precision is critical when we look at the policy shifts driving advanced facility programming. Municipalities are tightening regulations on complex public safety infrastructure, particularly law enforcement facilities, secure evidence storage, and tactical training centers. Recent public safety facility updates show a 15% increase in mandatory upfront programming validation checklists. Policy now demands rigorous upfront programmatic verification. If you do not map out exact operational workflows, physical security boundaries, and specialized ventilation demands before touching schematic design, municipal code and safety policy will reject your submittals. 4. Adaptive spatial reuse. Architecture is also being heavily altered by urban planning policy regarding adaptive spatial reuse. Commercial office vacancies hitting historic regional levels have sparked a 22% increase in civic conversions over the past year. This forces architects to navigate complex retrofits within a highly rigid structural envelope. Policy compliance and fiscal discipline in adaptive reuse mean executing deep upfront spatial validation before assuming an old office floor plate can safely support public infrastructure. Segment 2. Engineering, infrastructure, twins, and live telemetry. 5. The infrastructure scale-up. Municipal engineering departments are currently operating under intense public budgetary oversight and audit scrutiny. Recent municipal capital audits have flagged up to 35% of public infrastructure bills for strict EVM monitoring. Asset owners are actively using strict earned value management (EVM) metrics to track project health. If your metrics dip due to poor engineering coordination, municipal funding policies allow stakeholders to halt your cash flow immediately. Engineering performance is now directly tied to financial visibility. 6. Digital twin proliferation. Traditional static MEP models are losing ground rapidly to live performance streaming digital environments. In fact, traditional non-streaming MEP models have seen a 30% drop in owner acceptance across new institutional contracts. These twins are no longer passive handover documents. They actively monitor operational efficiencies, energy drawing, and mechanical tolerances. This gives owners a breathing asset that predicts maintenance cycles years before mechanical system failure. 7. Resilient facility engineering. To engineer these systems, our technical teams are facing intense human capital pressure due to resilient facility engineering. High-density public hubs are overhauling standby power, microgrid integration, and heavy HVAC redundancy standards to meet stricter climate resilience codes. Newer municipal microgrid codes require a 2.0 times redundancy multiplier for critical backup power arrays. To design these spaces, your people must be pushed to build deep, specialized technical literacy far beyond standard engineering practices. 8. The sensor-driven envelope. Deep foundation infrastructure projects have seen a 25% increase in fiber optic smart sensor integration over the past 2 quarters. Structural engineers are embedding smart fiber optic sensors directly into deep foundation elements on major capital projects. These sensors stream real-time settling, load distribution, and structural stress metrics straight into the digital twin. This bridges the physical and digital worlds, demonstrating that modern engineering foresight relies on a continuous stream of live data. Segment 3. Construction, field automation, supply chains, and pracademics. 9. Autonomous information environments. Field data indicates that transition into automated data workflows reduces manual data administration hours by up to 45%. Project staff is completely moving away from the slow, manual, adversarial culture of traditional RFIs. Instead, they are adapting to automated data systems that dynamically flag discrepancies and distribute data without waiting for a manual email. This shift requires our people to pivot from reactive problem solvers to proactive data managers, boosting field performance. 10. Supply chain lead time realities. This human adaptability is tested daily by the realities of supply chain lead time. Volatile lead times on specialized mechanical components and microchips have stretched past 42 weeks, completely dominating critical parts on public builds. Because these lead times remain highly volatile, procurement can no longer be an afterthought managed in a silo. Transformational construction leadership means upskilling your project managers and superintendents to integrate procurement timelines directly into early coordination, so the field never sits idle. 11. The ISO 19650 standard in action. This level of coordination is made possible on the digital side by the ISO 19650 standard in action. A recent industry adoption study reveals that 55% of major general contractors now mandate strict ISO 19650 data environments for their subcontractors. General contractors are moving away from loose data management and mandating strict international information management standards for all subcontractors. This data policy ensures every trade operates within a unified, federated, common data environment. When you enforce this policy, human error in data translation vanishes, and the model matches what is actually delivered to the field. 12. Pracademic field operations. Field metrics demonstrate that data-driven superintendents deploying precisely academic project controls lower field schedule variance to under 3%. The most successful superintendents, construction managers, and field directors in the market right now are acting as true pracademics. These are professionals who seamlessly bridge academic project management theory, rigorous data standards, and real-world field execution. They understand the why behind the metrics, and they use that knowledge to advance the baseline competence of everyone on the job site. Summary and call to action. To wrap up our June field review, let's take our rear-view analysis of architecture, engineering, and construction and apply 3 immediate actions this month. 1. In architecture, audit your design performance by locking down spatial data early to prevent the changes that account for up to 70% of downstream delays, protecting your programming and navigating strict code policies. 2. In engineering, align with live data streams by embedding strict EVM controls to avoid public capital audits and deploy fiber optic telemetry and digital twins into your infrastructure projects. 3. In construction, elevate your people by joining the 55% of market leaders enforcing strict ISO 19650 data environments and challenge your field teams to operate as true pracademics to drop variance below 3%, directly advancing the baseline expertise and competence of professionals across your entire operation. If you found value in this deep dive, hit that subscribe button, drop a comment below with which of these 12 points is hitting your desk hardest this week, and share this video with an AEC leader who needs to update their playbook. That concludes our field review for today. This is AEC Leadership, where we bridge the gap between academic theory and industry practice to advance the expertise and competence of global professionals. To our practitioners and emerging leaders watching around the world, thank you for tuning in. If you want to master the 3x6 framework, your definitive blueprint for operational excellence, strategic foresight, and transformational leadership, make sure to subscribe and turn on notifications so you never miss an update. For deeper professional development resources, visit our platform today and help shape the future of the built environment. Until next time, remember, competence is not a static state. It is a continuously validated trajectory. Build your expertise not as a summit, but as the platform from which you orchestrate leadership. I'm Dr. BTA. Keep moving and keep building. Thank you for watching, and I will see you in the next Rearview Field Assessment for July.